Hello, it's Matthew here, and we'll be looking at question 8, which is worth 50 marks. So we're shown the top of a lighthouse, and we're told that it's in the shape of a hemisphere, which is on top of a cylinder, and they both have a radius of 3 meters. So the first question is asking us to find the volume of the hemisphere. This is our hemisphere here. So we need to find the volume of that shape there. So let's have a look in our formula and tables book, and let's see if we have any formula for the volume of a hemisphere. So you'll see that on page 10 of your formula and tables book, while we don't have a formula for a hemisphere, we do have a formula for a normal sphere. And the formula for the volume of a normal sphere is 4 over 3 pi r cubed, and it's the very last formula on page 10 in your formula book. And you'll see there's a picture of a sphere there on the left hand side. And you'll notice the difference between a hemisphere and a sphere is essentially a hemisphere is just half a sphere. Some people use the word half sphere, but to be mathematically correct, we use the word hemisphere. So if the volume of a normal sphere is 4 over 3 pi r cubed, to find the volume of a hemisphere, you're going to halve the volume of a sphere. So let's look at it like this. So you're halving 4 over 3 pi r cubed, as the volume of any hemisphere will be just half the volume of the sphere that has the same radius. So we can just multiply a half by 4 over 3 now, which you can do. And if we do 1 over 2 by 4 over 3, you'll see that that's equal to 2 over 3. So therefore, the volume of a hemisphere is given by 2 over 3 pi r cubed. Now, r stands for the radius, so we're actually told what the radius is in our question here, and we're told that the hemisphere and the cylinder both have a radius of 3 meters. So that means here that r is equal to 3. So now I can pop this into my formula, and remember I'm using this formula over here, as our shape is a hemisphere, not a sphere. So that's going to be 2 over 3 pi by 3 cubed. And once again, we can pop this into our calculator to see what we get. So 2 over 3, and then pi. And to get pi on your calculator, you can just click Shift, and then see the button that's multiplied by 10 to the power of x down on the bottom row in the middle, right here. You'll see that that has a pi in yellow above it. So clicking Shift and that button should give you pi on your calculator on the screen. So you should have 2 over 3 pi by 3 cubed. So make sure to put the 3 in brackets like this. And then you can click x to the power of 3, which is up here at the top. And then you get 2 over 3 pi by 3 cubed. And we can click equals to now. And that gives us 18 pi. So the volume of the hemisphere is 18 pi. Don't forget your units. In this case, it's meters cubed. Meters because the radius is given as 3 meters. And cubed because the volume of something is always meters cubed or centimeters cubed. It's just the units of whatever it is, so in this case meters cubed. So our answer anyways is 18 pi meters cubed. So that's our answer for A part 1, and that was worth 5 marks. Now let's have a look at A part 2. And A part 2 tells us that the volume of the cylinder is 36 pi meters cubed, and we have to work out the height. So let's go back to our formula book and see what the formula is for the volume of a cylinder. And the formula for the volume of a cylinder is also on page 10. It's the second formula on the page. And it's equal to pi r squared h. Now our question is slightly different in that we're given the volume and we have to work out the height. So normally you're given the radius and the height and you have to work out the volume. So we're essentially working backwards here. So let's give it a go. So this is my cylinder here, and we don't have the height. That's what we're trying to work out. However, we do have the radius, and the radius is 3 meters. We're also told at the start of the question that the radius of the cylinder is 3 meters as well. So now we can pop in 3 for r, and we're also told what the volume is. So we can pop in 36 pi for the volume, and then we can solve for h, which is the height. So as I said, we're told that the volume is equal to 36 pi, and we're told that in the question. As I showed you there, the radius is equal to 3 and we don't have h, the height. That's what we have to try and work out. So let's pop in these values for v and for r. So you get 36 pi equals pi by 3 squared h. So 3 squared is 9. So you get 36 pi is equal to 9 pi h. Now remember, we want h by itself, not 9 pi and h. So to get rid of the 9 pi on the right hand side, I'm going to divide both sides by 9 pi. So that gives me 36 pi over 9 pi, and 9 pi h divided by 9 pi, both of the 9 pi's will just cancel, and we'll be left with h. And that's exactly why I divided by 9 pi, so that I'll be left with just h on the right hand side. Now we can do 36 pi over 9 pi. So remember, to get pi you click shift, and then the button with multiplied by 10 to the power of x, as that has pi in yellow above it, and that gives you the pi. So 36 pi over 9 pi, and that's equal to 4. So the height of the cylinder is equal to 4 meters. So that's my answer for A part 2, and that's worth 10 marks. Now let's have a look at the next part of the question. So we're shown two diagrams. The one on the right shows part of the base of the lighthouse where the top is being removed, and the diagram on the left hand side is the base of the lighthouse before the top part has been removed. So let's work out what question B part 1 wants us to find, and it's asking us to work out the size of the angle at the base of the cone marked A in the diagram. So that's this angle here. So we need to work out what that angle is equal to. So we're told that the height is 47 meters from here to here. So in other words, the length of this line here is 47 meters. And now this makes the question slightly easier for us. So now you can see our right angled triangle there with sides 47 meters, 7.5 meters, an angle of A, and we don't know what the third side is equal to, but that's okay, we don't actually need it to answer the question. So I'm just going to remind you now of the trigonometric ratios. So you have sine of some angle, which I'm going to call theta, and that should be equal to the opposite side, which I'm going to call O, over the hypotenuse, which I'm going to call H. You have cos of some angle, which I'm going to label cos theta, and that's equal to the adjacent side, which I'm going to call A, over the hypotenuse, H. And finally you have tan. So tan of some angle theta is equal to the opposite side, O, over the adjacent side, A. So whenever you have a question involving trigonometry and angles, or indeed sides, I always like to mark in my sides with either O, A, or H. Now you should most of the time have at least one or two of these. Sometimes you're given all three, however that's quite rare. In this question here, we're given two of them. So let's work out what we have, and then we can work out if we're going to use sine, cos, or tan. You can use sine, cos, or tan to work out an unknown angle when you have two sides, or to work out a side when you have an angle and at least one other side. You must have a right-angled triangle to use these. So looking at my yellow triangle there, I'm going to label my sides. So the first side that I always label is the hypotenuse, and the hypotenuse is always the side directly across from the 90 degrees. It will also be the longest side. So my 90 degrees is here. I can clearly see that that side across from that is this side over here. So I'm going to label this side H. Next I'm going to label my opposite side, and it's opposite the angle. So if A is the angle, the side opposite the angle is going to be this side over here, and that's 47. So my 47 is the opposite side, O. And finally, the other side is the adjacent side, so 7.5, I'm going to label that as A. So now we can clearly see that the two sides I have is the opposite side and the adjacent side. And looking at our trigonometric ratios, we can see that tan uses the opposite and the adjacent. If you aren't familiar with sine, cos, and tan, I do recommend learning them before the exam, as they are extremely useful and you will need to know them. There is a version of them in the formula book, however, I think it's better to learn it like this, but feel free to learn it in the formula book if you find that helps you as well. So my angle is A, so I'm going to say tan A equals to the opposite, which is 47, over the adjacent, which is 7.5. So I get tan of my angle A equals 47 over 7.5. Now I don't want tan A, I just want A. And whenever you want to find an angle with one of the trigonometric ratios, sine, cos, or tan, you're going to move the ratio over to the right hand side and it's going to go to the inverse. So here it's going to be A is equal to tan inverse of 47 over 7.5. So now we can work this out on our calculator. So first of all, for this question, make sure that your calculator is in degrees, as we're told to give our answer correct to the nearest degree. So if it's in radians, click Shift and then Setup, and then change the degree from radians to degrees. You can tell by the D on top here that my one is already in degrees. So now I can find tan inverse of 47 over 7.5 by clicking Shift, and then whatever the trigonometric ratio is that I'm trying to find the inverse of. So in this case it's tan, so it's going to be Shift and then tan to get tan inverse. Then I'm going to do 47 over 7.5, and that gives me 80.933499726, and correct to the nearest degree, that's going to be 81 degrees. So the angle A there is equal to 81 degrees. So that's my answer for B part 1 of the question, and that was worth 5 marks. Now let's have a look at B part 2, and here we're asked to find the distance K marked on the diagram, which is the height after the top part has been removed. So we have to find this distance here. So I'm going to explain now how to solve this using similar triangles. There might be other ways to solve it as well, but in my opinion, similar triangles is the most straightforward way to do it. But feel free to try your own method and you should get the same answer if it's the correct method. But this is the way that I'm going to do it, as I think it's the simplest method. So you see my yellow triangle there on the left hand side. I'm going to draw in a similar but smaller triangle to that on the right hand side diagram, which is right here. So now that pink triangle and the yellow triangle are both similar, as the angles in both of them are the same. However, one of them is clearly smaller than the other. But because the angles are all the same, we can say that they're similar. That's what a similar triangle means. The angles are the same. The sides don't necessarily have to be the same, but the angles must be. But obviously one of them here is much smaller, so the pink one is much smaller. So I'm going to call the length of this pink line here, the height of the triangle, I'm going to call it x. And we already have the base, which is 3. Now we already know that the height of the full thing is going to be 47 from here to here. And we know that from the diagram on the left, and we're also told that in the question. So I know that if I find x, I can take it away from 47, and then I'll be left with k. So my job now, and our job, is to find out what x is equal to. So with similar triangles, that means the proportion between both of them will be the same. So I'm going to start with the yellow triangle, and I'm going to put the height, which is 47, over the base, which is 7.5. Now, as their proportion is the same in the pink triangle, I'm going to put the height over the base of that as well, and put it equal to 47 over 7.5. Once again, this is because they're supposed to be similar and have the same proportion. So my height in the pink one is x, and my base is 3, so I get 47 over 7.5 is equal to x over 3. Now I must also say that there's some other combinations you can have of this as well, but as long as the corresponding sides are in the same places on both sides, that's the main thing. So now we can do cross multiplication. So for those of you not familiar with cross multiplication, you're just going to multiply across the way like this and equate both of them. So to put that into practice, that means 7.5 by x should be equal to 47 by 3. And 47 by 3 is 141. So now to get rid of the 7.5, I don't want 7.5x, I just want x. I'm going to divide both sides by 7.5. So 7.5x divided by 7.5 leaves me with x, and 141 divided by 7.5 leaves me with 18.8. So therefore the height of my smaller pink triangle is 18.8 meters. And remember what I said, we don't want the x there, we want k. But now that we have the x, which is 18.8, I can take that away from 47, and that will give me k. So if you take 18.8 away from 47, you're left with 28.2. So then k is equal to 28.2 meters. And that's our answer for B part 2, which is worth 5 marks. Now let's have a look at the next part of the question. So this is straightforward enough. We just need to work out the area of the circle with radius 40 kilometers. And we'll go to our formula and tables book to try and find a formula for the area of a circle. So it's on page 8 and it's the very last formula on the page. The area of a circle is given by A is equal to pi r squared. So let's go to our question now and fill in r and get the area. Now of course it's a circle with radius 50, so r is 50. So then the area is equal to pi by 50 squared. And we can pop this into our calculator to see what we get. So once again, click shift and then the by 10 to the power of x button for the pi above it. Then in brackets, and make sure it's in brackets, do 50 squared. To get the squared, you do the x to the power of 2. And then you get 2500 pi. However, be careful, it doesn't want the answer in terms of pi. So you must click this S to D button right here, just above the delete button. And that will change it into a longer decimal. And this is the true value, which is 7,853.981634. So to the nearest kilometer, that's going to be 7,854 kilometers squared. And once again, don't forget your units or you may lose marks. And C part 1 there was worth 5 marks. Now let's have a look at C part 2. And here we're told that 50 kilometers is equal to 27 nautical miles. So now we have to use this to work out how many kilometers are in 1 nautical mile. So we're told 50 kilometers is equal to 27 nautical miles. Now to get how many kilometers are in 1 nautical mile, you just divide both sides by 27. Now, if you're able to understand that, that's fine, but I'm going to explain to you now why it's divided by 27. Because think of it, we want to get the amount of kilometers in 1 nautical mile. So to get the nautical miles on the right hand side here to be equal to 1, I got to divide 27 by 27. Because 27 divided by 27 is 1. So if I divide both sides by 27, as you can't just divide one side by 27, you must do it on both sides. So I'm going to divide 50 by 27 as well. And then I get 50 over 27 kilometers is equal to 27 divided by 27, which as I said earlier is 1. And that's why I divided both sides by 27, is to get 1 on the right hand side. So we get 50 over 27 kilometers is equal to 1 nautical mile. So let's see what 50 over 27 is equal to. So just click in the fraction, 50 over 27. And we get the fraction again. However, we want it as a decimal. So once again, click the S to D button just above the delete button there. And you get 1.851. But again, I want to make this bigger, so click the button again. And you get 1.851851852. Now, it said it wants it to 4 significant figures. So to 4 significant figures, don't get that mixed up with 4 decimal places. In 4 significant figures, the number before the decimal point counts as well, or the numbers. It's any number that hasn't got 0 on the, in the first number or in the last number, they're significant figures. So in this case, it's the 1.851, they're significant, but the last one will round up to 2, as the 8 before it here is bigger than 5. So that will bring this one up to 2. So my answer then is 1.852 kilometers equals 1 nautical mile. So that's my answer for C part 2, and that's worth 10 marks. Now let's have a look at the final part of the question, part D. So we're told that the lighthouse is 49 meters above sea level, and the angle of elevation of the top of the lighthouse from a ship is 1.2 degrees, and we're asked to work out the horizontal distance marked D, which is from the ship to the base of the lighthouse. So we actually have a right-angled triangle marked in here for us, so it's even easier than the ones before. Once again, as I said, the first thing I like to do is mark out my opposite, adjacent, and hypotenuse. So I always start with the hypotenuse, which is the side across from the 90 degrees. In R1 here, the 90 degrees is on the right-hand side over here. So my side across from that is going to be this side over here. So I'm going to label that H. And then I'm going to label my O, the opposite, and it's always going to be opposite the angle given, which in our case here is opposite 1.2 degrees, which gives me 49 meters. And then finally, the third side must be the adjacent, so I'm going to label the D as A for adjacent. Now, the side that we have here is 49 meters, so I'm definitely going to include the opposite. And the side we're trying to work out is the D, so the adjacent. So I have the opposite, and I'm trying to work out the adjacent, so that means I'm going to use tan. I don't have the hypotenuse, so I can't use h, and I'm also not trying to find it, so we don't have to worry about h at all. This time we have the angle, so it's not going to be a for the angle or theta for the angle. We'll have the angle as 1.2 degrees. Now we have the opposite, and we're trying to work out the adjacent. So when you're using the opposite and the adjacent, that's going to be tan. And if you forget that, remember what I said in part B of the question. Tan theta is equal to O over A. So theta is 1.2, O is 49, and D is A. That's going to be tan of 1.2 equals 49 over D. I don't want the D underneath the fraction over here. So whenever you have a fraction, and you don't particularly want a fraction, we don't want the fraction here, we don't want D in the fraction, we want D by itself, you can multiply the fraction by the base of the fraction to get rid of the fraction. So I'm going to multiply 49 over D by D, but if I multiply that by D, I must also multiply tan 1.2 by D. So then on the right hand side, the D will cancel with the D, I'm left with 49, and that's what happens when you multiply a fraction by its base. You just get the number on top, as the base will cancel with the number you've multiplied it by. But don't forget to multiply the other side of the equation by the same number as well, or in this case by the same variable, or as we said, D. So then I get D tan 1.2 is equal to 49. Now I don't want D tan 1.2, I just want D. So I'm going to divide both sides by tan 1.2, as tan 1.2 divided by tan 1.2 is equal to just 1, so that would be just D then on the left hand side, because D by 1 is just D. So then I get D is equal to 49 over tan 1.2, and we can do this on our calculator. So type in the fraction, and then on top you can click 4 and 9, and then click the down button, and then click tan of 1.2. Once again, make sure your calculator's in degrees, as if it's in radians it won't work, unless of course the question is in radians, but in our case here it's in degrees, and we can tell that by the degree symbol, it's 1.2 and then the degrees. So you get 49 over tan 1.2, and that equals 2,339.235569. But be careful, the question asked for the answer in kilometers. So we need to convert this from meters, which is to now. And the reason it's in meters now is because the 49 is in meters, see there? So I'm going to need to convert that now to kilometers. So there's 1,000 meters in a kilometer. So to go from meters to kilometers, you divide by 1,000. So I'm going to divide 2,339.235569 by 1,000. So I'm going to do this on my calculator. So 2339.235569 divided by 1,000. And you get 2.339235569. So to two decimal places, that's going to be 2.34 kilometers. The other way of doing that would be to convert the 49 meters to kilometers at the start, and then your answer would be in kilometers. It's all the same. Both ways, you should end up with 2.34 kilometers. So that's the horizontal distance D. So that's our answer for part D of the question, and that was worth 10 marks. That was the final part of the question and the end of the video. Thank you very much for watching, and I hope I helped.